Hello, everyone. Hi there. So I am Chip. Thank you so much for coming to my talk. My career has been mostly with building AI systems, like trying to make AI useful in the real world. So I started with NVIDIA, and then I worked on 𝗦𝗲𝘀𝗀𝗶𝗁 AI, which is a data company, and then I started another AI infrastructure startup, which is sold. And since then, I'm doing a new company, which is in robotics. Anyone here is into robotics? One person? So it's just a bunch of robots that I work with. Like this one, I'm trying to fit the ring on the robot hands, which is weird because they don't quite have the same width as human fingers. But so today's talk is about software defensibility, because those are the kind of questions that I've been trying to think about in the last few years. Because there are two things that I thought of myself as being good at. One is writing, and the other is coding. And I think that those are the top two things that I could easily automate nowadays. So it made me feel okay, so what should I do that I can reasonably defend in the age of AI? So how many people here consider yourself software engineer? Well, a lot of you. How many of you are worried about AI automating your job? One person? Okay, few more people. I feel like this kind of thing you don't say out loud, It's yes, it's keep it a secret. Okay, so one thing that I keep hearing, people telling me is that the cost of building software is approaching zero. So I keep hearing people saying, okay, it's extremely cheap right now to generate code, right? You can just get AI and it can write you an app, a feature, build a website, extremely fast. So I keep hearing companies who in the past, maybe they could only create maybe 10, 20 variations for A/B testing. Now they could generate 1,000 variations for A/B testing because the cost is extremely cheap. So it made me think about okay, if the cost of building software is approaching zero, does it mean that the value of building software is also approaching zero, right? If the cost is zero, then the value is zero. So it makes me think about it made me realize okay, what should I be building, right? What is the point of building anything nowadays if there's no value associated with it? So a few months ago, I had launched a side project. It's a weekend project, and I like it. It's fun. It got some traction, my 300,000 views within a weekend. And then within a day, somebody emailed me saying that, I love what you did. So I asked 𝗏𝗏𝗀𝗏𝗏 to do exactly that. And here's a link to the website, look exactly what you just built. So I felt very ambivalent about it, right? I was on the one hand, I'm flattered, thank you. But on the other hand, what the heck, man? You just literally took it and copy and paste it. So it makes me realize it's any software that exists today can easily be replicated, right? If you can ask AI to do Airtable, it can build it. If you ask to build Asana, it can build it. And I see there's a lot of this. I'm actually building this side project. It's called 𝗦𝗽𝗀𝗏𝗃.com, where we can vote on which product is gonna be killed by AI first. I'm launching it next week, hopefully, and you guys can use 𝗏𝗏𝗀𝗏𝗏 or Codex to replicate it. But yeah, so I'm just curious about things. So it made me feel more excitement because now I can build anything that I want, but at the same time anyone can build anything that I want. And of course not everything is the same, right? People are talking about okay, not everything can be easily buildable because you cannot just build Google in a weekend, right? But at the same time, I see that, are you familiar with Meteor, METR? So they study the progress of AI automations. And they do a benchmark okay, let's take all the tasks that usually take let's say an hour. How often that AI can reliably complete the task, right? So it benchmarked on the length of tasks that AI can complete about 50% of the time. And you can see this okay, in the beginning, it starts very little, a few seconds of the task, but now it can reliably complete tasks that takes 16 hours. So it's a very long horizon, extremely complicated task, right? Because I feel that for a lot of engineers, I don't think people can just sit down for 16 hours and code something extremely complex. So things have been getting very complex. So maybe like AI cannot build Google nowadays, given the trajectory. So this is log scale, by the way. But if you do like linear scale, it will look like very much like a exponential. So things like AI can, at some point, get there. So I think it's like the Ghibli moment of software. So did anyone use OpenAI to generate Ghibli picture style of yourself? So in the past, right, I feel like there's a trend of like everyone using image generation to generate a style of Ghibli. And I think like I was thinking that there's no way Ghibli agrees to this. Like there's just no way. But then so at that point we think of like a style is something like if you can describe a style, it's a shorthand for the AI to know what to do. And the artists were very upset, right? Because they spent the whole career developing a style and people can just do it. And I think it's similar with software. Like anything that exists, just make it easier for people to like shorthand and build it, right? Maybe if I want to be something like Asana, it takes me a lot of time to describe, okay, here's the specs, here's the functionality, here's the workflow. But if it already exists, I can say, okay, let's just do it. Like you know what it is, right? So by the act of you putting out the software, you make it easier for the competitors to like do exactly what you want. So the question we think with AI is no longer how to build. Like if you know what you want to do, it's very easy. The question is just like what to build, and then once you build it, like how do you defend it? So I'm curious, it's like, what do you think could be the moat for your product? Anyone here is doing a startup? A few more. So I'm curious, like, what do you think would be the moat for your software startup? Huh? Proprietary data. So who here thinks that data is a moat? A few people. So you think that if you have a lot of proprietary data, competitors cannot compete with you? Okay, what else? What else would you consider like a moat for a company? Huh? Huh? Trust, like branding, trust branding. It's another very interesting question. Who else? What else? Customer service. It's a human layer. So when you say customer service, it's like AI agent as customer service, or? I see. Interesting. I feel like more and more I veer toward like just not going through human service. I feel like if I can get away with it, I would probably like try something automated. But it's interesting. So the question of trust, I think it's like people have been realized it's like trust is not sufficient because in the past, people were a lot more loyal to a product. But with AI, because the step change, like the improvement is so significant, so you can see people switch models very quickly, right? When ChatGPT first came out, everyone thought like, okay, there's no way something can compete with ChatGPT, right? And then suddenly like Claude, Anthropic came out and said, okay, now I can do it. And then DeepSeek came out and a lot of people jumped to it. And then DeepSeek turned out to not work quite well. People jumped to Quen. So I think like a lot of like the product we have seen that customer loyalty is hard to compete with like improvement, like product improvement. But I think that I definitely agree with you. Just like building trust is never gonna be a pain. On the question of like data, so data is I used to think that like proprietary data is a moat, right? Because if you have a lot of data, then people cannot compete with you. But then I realized like given how much money companies are spending on acquiring data, then data is no longer a moat. Like money is a moat, right? If you have money, you can just buy it. Have you seen a lot of AI frontier labs buying companies just to get the data? Have you seen that? So like if you look at the frontier labs, the list of their acquiring companies, like some of them acquire company like 2 or 3 companies a week, because the reason is just like acquire companies so that they can get data from that company. So maybe the competitors do not have the data, but maybe a frontier lab can acquire the competitors' data and then build something that's like work quite well for the use case. And it's quite interesting because given how fast people were able to build a model, launch a new model to compete with existing models, it turned out that like acquiring data is not the hard part anymore. And if data is anything, it's more like commodity. So let's say that like you have a QuickBooks, right? And I may say QuickBooks would never sell data to OpenAI, but OpenAI can just go to like Scale AI, search Micron, and say, okay, now create a software that looks exactly like QuickBooks. Hire like 10,000 accountants that do all the workflow you need as if you were using QuickBooks, and then use that data to train the model. So like people can do that pretty quickly, and that's why like all this data labeling companies are like have revenues like $1 billion, just because they create a lot of that like extremely fast. Another thing that people told me about is like distributions, right? Especially for enterprise. Let's see, they have spent like months and months trying to get the software into the customers, and they work with like, I don't know, like oracles and like stuff like, I know, it's very much embedded into the ecosystem. It's extremely hard to like for people to like move away from it. I think it's like there's still a lot of validity in it. But I also want to ask about like, okay, how about for consumer products, right? And some things that's like do not require heavy integrations. And a lot of people was like, oh, actually do not know, right? Because a consumer product like this and that is like a pretty much easy issue to replicate. And also like having like distributions as a mode also make me feel a bit uneasy, because like the entire mode strategy depends on people's annoyance, right? Like something that makes it extremely hard to use so that people cannot get off your platform. And also another interesting model is that like, so I have a friend who used to be like a partner with a very big firm, like PB firm. And he tried to sell to a lot of manufacturers, right? And if you go through the old school project, old school approach, you have to go reach out to all these manufacturers and like, okay, try to sell to them. And what he did was that, okay, he just bought a software company that already has like 10,000 factories as a customer. He was like, okay, these software companies, they're not AI companies. It's actually a lot cheaper. Like if you have AI money, you can go and buy these companies, and that way you can own the distributions. So distribution in a way can be acquired with like more money. Another thought about is like expertise. So people was like, okay, but like I know the domain the best, right? I have like years and years of like iterations and make it the best. But like expertise is also interesting because expertise, like for it to be useful, you have to encode it somewhere, right? You don't want to be a service model when you can just like use like exchange service for like hourly money, right? You talk to people or not. So you want to just scale it. So that means you have to encode that. And now expertise becomes software. And like all the workflows you spend years and years design can be just copy, and like people can just use that as a workflow. So I think there's only one thing that I realized is just like what I thought of is like momentum. So the only way to spend ahead of like customers, like your competitors, is just like you move faster than them. Like, and I think like it makes a lot of pressure for like a lot of companies, because now you want to build a product, you're like committed to like a never-ending treadmill of like just doing faster and faster than the competitors, which is like for a lot of people it's great, like people love it, but it's just like create a lot of pressure on the part of like of like how to stay with your competitors. How do you feel so far? Is this like too bleak? So I think the question of like what you build, I think it's like a lot of I do think it's like there's a lot of value in building, because buildings, one thing, I do spend a lot of time, like right now I have like both Cloud Code and like Codex running, because I feel like I just like building, and building things I feel like it makes me a better problem solver, like, right? It's like, because when you building, you don't build products that exist in a vacuum, right? You build something to address and some annoyances that you have. So being able to like building just like help me understand the problems I want to solve more, and have the experience of like, okay, here's a problem, here's a solution I think would work. Let's build it and launch it, and I put it in front of users and I see like what they say about it. But if you want to build it as a company, like as a startup, then you need to think about like not just like today, but like how it's gonna work like 2 years from now on. Because one of the cases I actually like invested in this company, and they did great for the first 3 years. Like for the first 3 years, they grew from like 0 ARR to like 10 million ARR. And now they just cannot like, they just don't know. Like, okay, now we have 10 million ARR, but then they cannot get to 100 million ARR. And if in a lot of VC world, like it's kind of stuck, right? Like you're not gonna be big enough to go IPO, but then you can't also like, then what do you do next? So I think it's very easy to get like keep on building, see early momentum, and then don't know if you don't have a strategy of like going big, it's hard to raise money. So one thing is like I do have this belief that like no matter how good AI is, there will always be problems to solve, because I think it's like no matter how good AI is, I would never stop being angry at like people on the internet. Like I would never stop being angry at like United customer service, right? I mean, there's a lot of like problems that it's just like AI will not solve. And I do think it's like as AI become better, it expands the surface areas, right? As like AI like allow us to build more use cases, as it expand, like it might not be the same problems that we had before, but I introduce new problems. And I want to cover a few like categories of problems, things that have emerged with AIs. So before I go into that, I think the problem is a long tail problem. It's a long tail distributions. So like there are problems that like everyone face, right? Like everyone wants to write better emails. A lot of people want to write better code. A lot of people want like, want to like help with like small little things like, okay, fix my essay, do my homework. So these are like, they're like a category of very, very big problems that I do believe that a lot of AI frontier labs will try to get the models to do well on, right? Like let's look at them like, okay, here are the problems that faced by the 99% of the populations versus the problems that face maybe like 1% of the populations. The AI frontier lab will probably focus on the ones that like 99% of the population has. So that's one reason why like a lot of these AI labs still focus on like a few standard use cases, and like a lot of them still focus on English. For many languages, for example, like Arabic, AI actually doesn't quite work well. So I have a friend who is Iranian, and she told me the story. She's the professor at CMU, so she does a lot of work with like AI, and she told the story of like because she speaks Parsi. Is that a language? Farsi, right? Sorry, I feel very stupid right now. Yeah, Farsi. And she has an issue of like her friends would ask her to explain a sentence, like an idiom in Farsi. And she explains a sentence that like, oh, that mean like that. And that friend was like, no, you're lying. Because apparently ChatGPT gives a different answer to that different answer, and the friend somehow trusts ChatGPT more. Even my friends like, no, I am correct. But just because ChatGPT just doesn't do very well in like Farsi language, so there are a lot. So I also work with like a lot of the voice chatbot. And another problem with voice chatbot is that you have to like respond very fast, right? Like a human to human interactions, the latency is like you want it to be like under like 800 milliseconds for it to be like a good, reasonable, natural conversations. But like for voice chatbot, it actually go through 3 steps. So first step is to be able to translate from audio into text, right? And then you send the text to an LM to get back the response. And then you send the response to like what I call like text to speech to synthesize the voice, to send it back to users. So a challenge we have was that like this voice chatbot worked really well for English because like the speed of like synthesizing English is pretty fast, but for Arabic or Russian, extremely slow. Like it's make it really hard to create natural voice chatbots for different languages. So I think like see for a lot of long tail problems, I do see the AI labs is not quite doing it yet, and it doesn't mean that they're not doing it like 2 years from now on. But I can see that like if you can pick a problems that is, I think of them as big enough to be profitable, but not big enough that AI frontier labs will want to take the lunch. It's the kind of thing. Okay, so like here's some of the long tail problems that I could find like I thought is interesting. One is human preferences. Are you here familiar with ILHF? Have you heard of the term? Reinforcement learning by human preference. You heard of the term? So like in the early day of like LLMs, like in the early day of like GPT-4 and in the early day of these models, ILHF is one of the most popular terms that people want to understand. So the way the model they train the model is that like they want the AI to be able to generate responses that humans prefer, right? So it would give a prompt and it give like 2 responses side by side, and then the human will pick, okay, this is the one that I like more, and then you will use that to train the model to nudge it toward generating more like better responses. So a challenge with that is that like it's trying to encode human preference into one equation. So it assumes that there's some like universal preference, right? Like everyone somehow like prefers the same thing. So when I was going through the Anthropic IOHF data sets they made online, I realized it's like a lot of what people consider the winning responses Actually, I do not prefer the winning response. I actually prefer the losing responses. It's like somehow the note is like marked as not better. So human preference are extremely hard, and it requires to understand users very well. So going back to the voice chatbot, right? So humans actually have a very different preference to like how fast the other person responds. So I'm from Vietnam. So in Vietnam, people actually like prefer the other person to give them time before respond. So I have a niece who is like 10 years old, and I have my godmother who's like 70 years old, American woman. So I tried to put them on a call, and it was like the worst experience. It was so like when my godmother, she tried to be friendly, right? So when my niece took time to respond, my godmother was like, okay, she is shy, she doesn't know how to talk, and she didn't want the awkward silence. So she just kept like, if my niece like wait a little bit long and didn't say anything, my godmother was like kept on asking questions, right? And then after that, my niece told me, it's like, wow, she didn't give me any time to respond at all. So it turns out, so actually a well-known study about it. It's about like in the West, people actually like prefer conversation response rate to be very fast, maybe it's like 80 milliseconds. Like if you finish talking, you expect me to respond very, very fast. Whereas in some culture like Vietnam, like after you finished, you finish talking, like you give the person maybe like 200 milliseconds so that the other person can make sure the other person has finished and formulates a response. So like all of these nuances, you need to be able to understand the customers to build a product that works quite well. So I guess part of the expertise is part of the moat. Like it's more like user understanding who you're building for. Another thing is like the human AI interactions. And since we at Microsoft built, I want to talk about like a lot of you are like software engineers. How many of you are using AI to write code right now? Almost all of you, yeah. How many of you are using it via the terminal? Some of you, right? How many of you use it via like IDE? Like, how many use both? Okay, well, most of you use both. So like when I was looking, it's like Terminal is a very interesting product. So Terminal, I think of it as a more legacy product because do you think that Terminal is easy to use or hard to use? Who thinks terminals are easy to use? One person, right? Few people. So terminal, I like so when I start using terminal for like writing code, it's like got pretty annoying, right? It's very hard to move the cursor around. You kind of just like throw an image in there. Like it's like if you see like a user build website, it's like okay, this is like horrible interface. I want AI to see that like this is terrible, but I cannot easily drop an image in there. And it's make me think like why are terminals so hard to use? And it made me think of like, okay, terminals actually very powerful. Terminals are like the control plane for the computer, right? It's very easy to do stupid thing there. Like you can remove RF, like you can remove the whole operating system, and you could be like in trouble. So terminals, in a way, was designed to be hard to use on purpose, so that people who don't know what they are doing don't do something stupid by accident, right? So IDE, on the other hand, was just like makes it a lot easier to use. But then I think like I thought about it, it's like there's not really a reason why they need to be in a separate product, right? Like one of them is like ease of use, and the other like make it like harder to control. So I think of like, what if we have something that's like as a hybrid? And I think it's like a lot of those Codex desktop or like Cloud Code desktop or like the different desktop from like designed to be a mixture of it, right? Like it has the ease of use of like IDE, but then it also like allow you to access the file systems the ways that a terminal can, so that it make even more power of that. And another thing is about like people have quickly realized that like which also give like people quickly realize it's like have you ever walked around with your computer open because of Cloud Code or Codex is running on the computer? Yeah, I think I walk around the airport, and when I see somebody walking around the computer open, it's like, okay, that person has something running. So there's no reason why you need to do that, right? Because like, if you think about it, all the work is being done on the cloud. Like there's no reason why you need to keep the computer open to run it. But then, so like there's a lot of tools to like make it easy for you to access your, like to make your things run without the computer. So somebody likes to open Cloud in the early day. A lot of people bought the MacBook Mini. So the idea is that you have a server that hosts your agent so that you can just leave it run all the time. So you don't need to do the computer. And after that, it creates a whole challenge of like, okay, you need to like create a sandbox, you need to be able to like to recreate the environment. So now it has to be on the cloud, so you can access from a different device. And there are some people who create like mobile apps, so you can control the cloud code or codecs from the mobile phone. Somebody like, actually one of my fun projects was like, I can actually like control my cloud code from my Telegram bot. So you could send me like messages, okay, now it's done, they ask me yes, no question, like, okay, do it. So I think like all of that is like human AI interactions. It's like quite interesting. Another challenge, another example with like GitHub. I imagine just like a lot of you probably use GitHub for like code review collaborations, right? And one thing I noticed with like code review is that people don't review code the old way anymore. So I worked with a team recently, and the most senior person told me that he still review on the code line by line, right? Which is like shocking to me because it's like sounds so painful nowadays. Like I don't read code line by line anymore, right? This is too painful. But he said, oh, he did it because he want to be able to give feedback to junior engineers. So that they can learn, okay, this is not good or not bad. And then I went to the junior engineers and I'm like, okay, do you read his reviews? And they were like, no. And the reason they told me that because the feedback is not actionable. Because the senior engineer will say, okay, do not write this if-else function like this, write like that. But then the junior engineers are not the people who write the code, right? Like it can't just, it can tell AI like, okay, don't write this thing, but it's not going to be applicable for the future. So what the junior engineers want feedback on is like how to write the instructions for the code. And it's something I feel like GitHub is not quite designed for right now, right? Like because I think like with the new AI coding, the artifact is no longer the code. Like GitHub was designed around code as a main artifact, right? Like you have the code base, people like protect the code base. So code is the main artifact. But like nowadays with AI coding, like the main artifact actually is the instructions. Like how do you like the specs? I think some people call it spec-driven development. It's like how do you, like if you have a good specs, you can give it to AI, it can generate code maybe even better than like what you currently have. So I think it's a lot of work like thinking about designing like, okay, what could be the workflow for us to work with AI so that it can be more meaningful, because a lot of the workflows that we have nowadays are legacy. So I guess it's like also part of like human collaborations. It's like how do we get different people to work on a code base effectively with AI in the loop as well. And another category of tools of like problems that I find extremely exciting is the human AI environment interactions. So to make AI work better in production, right? One way to go is to make AI better, like can do things better. Another way to go is also make the world an easy environment for AI to operate in. So I do work, so like one thing with AI coding is that like people have noticed that AI works a lot better with new code bases, right? Like if we have a new code base, AI can just like do things. It also works a lot better with modular code base. Like, okay, if it's like, okay, just build this new functions. It's a lot easier than trying to fix the old code base. So there's a whole new category of like consulting firms that like go and retrofit the big existing code base to make them more friendly to like AI coding. So make it more modular with like different like separate a massive monorepo into like smaller repos and things like that. And another example is like there's also like API. So in the past, like a lot of the tools and apps were built for humans, and what humans want are like the GUI, right? Like the graphic user interface. Because humans, we are very visual. We want to be able to, like if we go to Salesforce, we want to open the website. We go and like see on like, okay, here's a button we want to click, and we want the color to look nice. We want things to represent it. But AI actually doesn't do very well with like on the visual, right? Like if you ask AI to do Salesforce thing, it would really want to code a bunch of like API functions. So we see that a lot of like companies like trying to like move a lot more of their design into like API design instead of like the GUI design. And I think it's very curious to see like the usage of like, for example, like let's say you have a a tool like Salesforce, you can see there's a usage on the Salesforce, how much of that was used by human and how much of it is used by AI. You can see the distribution changes like a lot like over time. Another thing more physical world. So I work a lot with robotics nowadays, and a lot of time a lot of the argument people have against general purpose robots is like, why do we need a robot that can do everything and work everywhere instead of just change my house or change the road to be better, like easier for robots, right? So one example is like, it's a food delivery robot. Do you know this little food delivery robot that like move around? I think in the South Bay you see them a lot. They're very cute. They're very tiny. They're short like this. So you can put the food inside and it take you to your home and you open it and it's adorable. So it was talking to the team, I was asking like, so what is a weird challenge you had with this robot? And they were like, oh, the biggest challenge was the robot couldn't cross the street. So when the robot go in the street and it needs to like the light to turn green, and a lot of street light need to press a button so that the light can turn green. But like the robots do not have arms. It's very tiny. So it cannot press a button to like cross the street. So somebody has an interesting innovation of like the robots can go up to a pedestrian and ask the person, hey, can you press the button for me? So there was some video of it online and the pedestrian was like, what is happening? Like this robot asking me to do manual labor for it. Like I should be asking it to do things, not the other way around. But yeah, but like he told me, it's like actually some cities, they have this kind of thing of like they're building like streetlight API. So that on this robotics company can actually access the city street light and they can tell like when the light's gonna turn green. And instead of pressing the button for the light to turn green, you can actually call the API to turn the light green. So that's one example of like getting the world to be more AI friendly long term. I think this is a whole field of it that I think that that we're still very early because we still don't quite know like what use cases are gonna be possible and like how we can make the world better for it. Another thing is like it's still pretty important for the robot to operate in the real world. It's what I call like irreversibility. So recently, Cloud Code actually deleted my database. So I asked it to do an app, and it wants to like deploy on a port, like on it's like a Docker Postgres port, and I have another app only using that port. So Cloud Code was like, I saw that the port is taken. Let me clear it so that we could deploy this app. And then it completely deleted the other Postgres database. Like, wow, smart. So I was mildly amused, but I was not frustrated because, I mean, I have a backup, right? So it was like, but it could happen, right? So for a lot of things that happens on your computer, there's like a way for you to revert what happened. Like Git is great for it. Like if you submit a PR or like make a commit you don't like, and revert to the old commit. But for a lot of use cases, you don't have that luxury. So let's say you ask an AI agent to like submit a form, right? After you submit the form, maybe the form, like the data now lives in somebody else's server. You cannot undo it unless you ask the server, the form owner to delete it for you. So you don't have that luxury. Like you cannot just like transfer money to another bank account and then ask the bank account to like transfer it back. They might, but if they are like a scam, the scammers they really want, right? So there are a lot of like things that like as we give AI more power, more tools, it's just the risk is just higher. So we need to design the whole system around like how to make it very, very hard for AI not to make mistakes, because mistakes can be very costly and not reversible for like many, many use cases. And especially like working in robotics, it's like more important than ever, because like if like a robot step on a child, I don't think we can just like revert that, right? Like the child's already hurt. So actually like one of the robotic companies I work with, they one use case that they get asked for a lot. It's like elderly care. Right, I'm not sure any one of you have deal with like elderly care. It's extremely expensive. Like some people pay like $20,000 a month, like to like take care of like an elderly parent. So the need for it is like very high. But like elderly care has a thing is like it's scary, right? But because a robot is heavy, and robots has very low batteries life. So like for example, like have you seen the Unitary G1 robot? It's like 𝗬𝗲𝗍, right? So it's like 80 pounds. So it's metal, right? Imagine that falling on you. That does not feel good. And you can do a lot of things to help with it, but like one failure mode is quite dumb. It's like this battery just dies. So let's imagine the robot's doing some walking, right? And then the battery just dies. say the board like mid action can just like flop over. So it's quite challenging. So like we're doing like things. Do you know about the one wheel accident? Do you know the one wheel? The one just like have one wheel and it can like go and ride around. It's like it looks very dangerous but very cool. So they have one failure mode that's like got them sued a lot. It's just like if you're on the wheel and the battery die, you can just like fly over there because the wheel is just like stuck there. So that could happen with robots. Let's say just like the robot like do a lot of actions and the battery die. It will just like have no control over itself. So there are a lot of like toolings work to make it safer. Like maybe detect like when the battery is like maybe like low, so they don't attempt like any complicated actions. Or like self-charging is a very important feature so that we develop. So like if we know it's a robot thing, okay, if we're gonna go out of battery, let's move back to the base. And also there are other rules that we can do like around like safety. Wait, how much time do we have left? Yeah, so I think like there's a lot of problems that we can build for AI, with AI. Like I'm actually pretty excited because one thing I realized is like with AI, I get to build more things because now I do not have to do a lot of boring stuff. I can just focus on like thinking about, okay, what kind of new things, new problem I want to solve. And a lot of this boring stuff, like to be fair, like I actually do not like manually writing code because in college, one thing I really hated was vectorizations. Right, like I had to do something. It's okay. You have to make it like super fast or like writing if-else function. I never found that very exciting. But now with AI, like a boilerplate code. Now with AI, we can do that a lot faster. So we talk about like software defensibility for the product. But another question that I also think a lot about is like how to make myself more defensible in terms of AI, right? Because like how do I make sure that like I can learn the skills that AI won't automate? So in the early day of ChatGPT, one thing that I did spend time on, and I would love to like learn more from like people, like how they do it, is what I call like a career audit. So for the whole week, I actually went through like and note down everything that I did, and I tried to think of like, okay, what can this thing be automated by AI, right? If it can, is there someone already doing it? Or if it cannot be automated AI, then like, or if it does not exist yet, then maybe I can build it. So they give me a lot of ideas, and so give me like a better understanding of like, so people call this a term of like AI exposure. Like what percentage of your job is exposed to AI, and the higher the percentage, like the higher chance of the job being automated. So yeah, I'm be curious to see like how people approach that. So I think like just to bring it home, I think about like any software that exists can be replicated. So I spent the last 2 years in my last company to think about like, okay, if that's the case, maybe should I go like beyond software? So I think of AI agents as AI agent is to perform actions, right? In the simplest form of action, it's just like tokens, like generate the next token, which is the early day of like ChatGPT, like LLM, right? It's just like keep on generate like one token after another. Should I turn into an essay, an email, question answering? And then the next category, next level of like actions are like digital actions, right? Now the agent can do fancy things. It can read file, it can write into file, which is like important for coding. It can call different APIs, it can GitHub API, it can call like image generation API, it can call whatever the banking or like internal API, external API. It can do search. Search is very important digital action. I think this is the next tier. I believe is physical actions. So for example, like now instead of like imagine, right? Imagine that you have an agent that like running some code, maybe in an OpenClaw or something on the terminal, and then suddenly it says like, okay, for this to complete this task, maybe I need to I need to build these small things. It can run out and like buy it. Or it can do like, okay, I want to do this task like hosting an event. Maybe you can think, okay, for hosting an event, I can like create a guest list, I can invite the guests, but I also need to go out and buy some like plate. Like if you can like get some robot to like do this physical actions, that could be super cool. So I do think it is another layer of like action in the real world, like to do physical actions. And I do think of this like physical AI agents actually do not look that different from like the AI agents that we know today. Because an agent is anything that can interact with the environment, right? take feedback from the environment and perform actions on it. So a coding agent, the environment here is like the computer, right? And the action it can do is like read file, write file, edit. So it can perform actions, like it can perform action in the environment by making changes to the file. It can get feedback from the environment. First of all, it can try to run the file, try to see if it complies, to see if it passed the test. So that's how like organization work. And it's the same thing with like physical agent, but now the environment is physical instead of just like purely digital. And the action here are more physical motions like walk, pick up things, placing things, pushing, pulling. And AI, we have seen that it has worked quite well with reasonings, right? With AI, with digital AI agent, we can see you can give it a task, it can reason through step by step how to accomplish the task, right? Like, okay, if you want to like build this app, first I need to like create a database, I need to like build this well, I need to like I need to write a script and things like that. And you can do, and I have seen that like AI can do the same thing for a lot of the tasks in the real world. Like, let's say if you ask it to like, oh, do laundry, you can first think, okay, first I need to collect all the clothes. Second, I need to like take them to the washing machines. I can do a lot of random things. So I think as the reasoning part is pretty good. I do think that I have pretty strong convictions that AI is very good at reasoning. AI needs to get a physical understanding, because it needs to go through, like for digital AI, a lot of the environments are very well described with documentations. Not everything is like has good documentations, but ideally a lot of APIs, you know like what endpoints you can call, right? Like you know it's like what parameters it expects, you know it's like, okay, here's the error code, you know what that means. But for physical world, we don't quite have that nice description of the world. Like there's no documentation about like how to handle an egg, right? There's no one to say, okay, if you put this much force into the egg, it will break. Or like if you like put the legs this way, you're gonna fall. So there's not good description of the like physical environment. So that's the part that we need to teach AI. Like we humans, we learn how to operate in the real world through like try and error, right? For a try, it takes like a long time, maybe a year or so, just to learn, just to walk, like learn to like control the muscles, the joint. We don't have that information encoded, encoded. And I think that's why there's a lot of effort going into what is called like world modeling, like trying to model the world so that we can teach AI how to understand and operate in it. But yeah, so I'm very excited about it. So we actually have one of the companies that I work with have a demo tomorrow. For the robots, they have this dog robot. Unfortunately, they kind of spare a humanoid. Humanoids are really cool to watch. But yeah, unfortunately, I think the dogs are also very cute. Yeah, if you want to come for it. And if you want to talk about robot, get in touch. I'm talking more about like, so I'm trying to write more about like software defensibility and like AI for robotics in general. Yeah, thank you so much, everyone.